Welcome, folks. I see some folks coming in from the waiting room. We're just gonna give it about a minute so that the waiting room can clear. I still see more joining. Thanks to those who just joined. We're just giving it a moment for folks to come in from the waiting room. Okay, I think that we've got the waiting room cleared, so we're going to go ahead and kick off. I would like to welcome everyone to this Linux Foundation Energy webinar, Introduction to SEAPATH. We are privileged to have with us today Erwann Roussy from Savoir-faire Linux, who will be presenting today's webinar. Just so everyone knows, this is being recorded. We will send the recording along with the slide deck out via email to everyone who registered following the conclusion of the webinar. In addition, if you have any questions at any time during the webinar, feel free to click the Q&A button in the bottom of your Zoom interface. You can then type your question. Once we get to the end of the webinar presentation, we will go ahead and answer all of those questions, or as many of them as we can in the available time, in the order that they were received. So with that, I'd like to thank you all for joining us, and I'm going to turn it over to Erwann to kick us off.
Thank you, Dan. So hello, everyone. I'm Erwann Roussy from Savoir-faire Linux, and welcome to this webinar, when you will learn about an introduction to the LF Energy SEAPATH project and various technical insight from the project. So just before beginning I will present myself. So I'm an open source consultant and an embedded software embedded engineer at Savoir-faire Linux. So we are a French-Canadian company, which are member of the Linux Foundation Energy, of course, but also the Linux Foundation and the Yocto project. And in 2022, we received the supplier trophy of RTE, so the French TSO, for beginning working on SEAPATH with them. Regarding the outline of the presentation, so I will first go on the project presentation, very general, what is it, and how it should be used for. Then I will go a bit deeper into the technical details to explain how SEAPATH is capable to run virtualized production and control, how we test that, and how do we ensure the requirements of those fields. Then I will talk a bit about the SEAPATH integration with hardware and software, and I will finish with the SEAPATH community, giving you all the useful links you have to answer your questions or to start your SEAPATH journey. So let's start with the project presentation. So what is SEAPATH and where does it integrate into the electrical substation field? The goal of the SEAPATH project was to be inspired by some industrial success in virtualization, so previous success. First of all, you have the data center infrastructure and philosophy. So it's a world where the big tech giants who use cloud infrastructure and don't use directly any physical hardware box anymore. So everything is virtualized, everything is running in virtual machines, and those machines are running in data centers. Why did they make this decision at the time? It was mostly to improve the flexibility and the availability of the software running on virtual machines, and also reduce the costs. So when they have multiple things to do on their hardware or on their infrastructure, they can do most of that directly in software, directly from the desk they are on. They don't have to go directly inside the data center to unplug some cables or put more hardware boxes, more hardware servers inside the data center. So that was the first idea, but the data center world is, of course, not the same as the substation, electrical substation, not the same requirements. But we have something in between, of course, which is the telecoms field, where for the 5G networks, this virtualization shift has been done also for the telecom. So when replacing all the physical hardware with software functions, so virtual machines indeed, which allows to reduce the infrastructure cost, to improve the management of the infrastructure, and also to facilitate the deployments. So it's much more flexible today than it was 10 years ago, before the 5G networks. And then here we are with the digital substation. So the goal is more or less the same, to switch toward virtualization. So digitalization first, which is already underway, but now to virtualization to lower the hardware cost and improve the management and the flexibility. So that's something that's really really think about by utilities to support the transition to smart grid, so that the old infrastructure can be more scalable and more agile. So the goal of SEAPATH at first was to develop an open source real-time platform. So to run the software needed for the electrical substation world, we needed a real-time platform, and we wanted to make it open source. This platform should also be industrial grade, so be able to run industrial ready products and industrial ready software. And we wanted also to develop a reference design in the same idea as the open source, so we can have many people around the table thinking about a reference design. This project should host virtualized automation and protection applications. That was the end goal, non-critical software on one hand, but also on the other hand, critical software like vPACs. And also from the very beginning, the SEAPATH project has been thought as a multi-provider system. So shall it be from the hardware point of view or the software point of view, it can be used in a multi-provider application. So what it means that we are not bound to any hardware platform. We want to be able to run on multiple platforms from multiple providers. And the SEAPATH project is not only able to run one provider virtual machines and one provider software, but to run multiple provider applications. So they shall all cohabitate on the same platform. Then the goal was to, of course, combine performance and safety. Performance is needed for the electrical world, and also safety because we are dealing with critical infrastructure. So what are the technical requirements from SEAPATH? From the very beginning, we wanted to look at what is needed and what we should develop. So going from the low layer level into the high layer level, first of all, we need the platform to be real time. The idea is to be able to respond into a bounded time frame, which is absolutely necessary for the electrical substation world, when you have to respond in a very short amount of time. In the same idea, the network should be with low latency, so receiving all the Ethernet frames and all the digital substation packets should be fast enough for all the applications to be able to respond in time. Then we wanted that it needed to be minimal services and configuration. This goes with the cybersecurity questions. So if you want to be secure, you need to look at what you install on the software and to install only minimal services and configurations. Then going a bit higher level, we needed that to be infrastructure as code, which is a paradigm I will describe later. But the idea is that you can have all your infrastructure described as code, as a language, programming language level. And from a very high layer point of view, we needed to be with high availability and to be able to run virtualization. The high availability question is the idea that if you lose anything, like if you lose a network connection, if you lose a cable, if you lose a physical machine, you should be able to detect that and to tackle with the problem automatically. So it should not require manual intervention to lose one of these elements. We will also describe all of that later in the presentation. And so the last stage is the virtualization, which is the base idea of the SEAPATH project. At first, we have looked at existing solution, of course, and did a little state-of-the-art question of what was already available on the market. And we couldn't find a platform that was doing all of the requirements that I just described to you. So with the virtualization platform, with the real-time and the low latency, most platforms were doing two of these three items. So you had virtualization, of course, but you had real-time low latency platform, but that didn't do any virtualization question. And on the open source world, at least, there wasn't any solution at the time. So the idea was to recreate a Linux distribution, but without reinventing the wheel, so without having to bother by recoding and redeveloping all of the applications, as I will show in a few slides. So here we are. That's the SEAPATH project. SEAPATH is really at the heart of the electrical substation. So you have on the right a schema, a basic schema of an electrical substation from an ISE 61850 point of view, so with the process bus and the station bus. The equipment at the bottom of the schema are directly sending information into virtual IEDs, so IEDs running inside virtual machines. And those IEDs are connected into the management, the HMI, and maybe a SCADA or any of these topics. And all of these IEDs are running on the SEAPATH project, on an hypervisor, a physical machine running SEAPATH, and on top of that, running virtual machines. So those virtual machines, of course, real-time virtual machines with redundancy. And all of that is designed to operate in a critical infrastructure. You can see also the redundant hypervisor on the schema on the right. But I will describe a bit more of that later. And we had tackle all our requirements, mostly determinism, so to be able to process the data with deterministic latency, resilience, so high availability, cybersecurity. We wanted that also to be hardware agnostic and with long time support, which is also something needed for electrical substations. That was the presentation at a high level. So now going back a bit into inside a hypervisor, inside the SEAPATH hypervisor, what does we use as software? So all of those are open source software and well-established open source software. At the very bottom, you have the Linux kernel with preempt real-time patches and configuration enabled, so to be able to run real-time applications. You have all the stack for high availability with Ceph, which is storage replication software to have a disk replication on multiple hypervisor. Pacemaker, which is a resource management on multiple hypervisor. All of that is dealing with the high availability question. OpenVSwitch is used for the infrastructure as code philosophy, so where it is better to describe software-defined network than to have a hardware-defined network, let's say. The very idea is that we don't have to unplug and plug again some cables if we need to change the topology. This is handled by OpenVSwitch, all of that in software. And from the rest, it is the virtualization stack. So mostly QEMU, which is a well-established virtualization software on Linux, which is used with the help of KVM to speed up some virtual machines and allow them to run directly on the hardware with bypassing the virtualization stack from the Linux kernel. And then libvirt, which is an API to ease the deployment of virtual machines and the infrastructure as code philosophy. On top of that, of course, you have all the virtual machines running inside the hypervisor that can be from multiple providers and different providers. One last very important tool that we use is Ansible, so which is used to do the infrastructure as code philosophy. So that's where we are going to write our infrastructure, write our different hardwares and our connections, and that's the tools also used to deploy all of that to ensure that everything is working correctly. Last topic regarding the very high-level presentation of SEAPATH is that SEAPATH is OS agnostic. So today we have two operating systems at the base of SEAPATH. The first one was built with the Yocto project. So the Yocto project is a Linux distribution generator, which is mostly used in the embedded world. The idea of the tool is that everything can be customized and everything can be minimized. There are many hardware supports, and people are fully independent to maintain it. So basically, the Yocto project is rebuilding everything from scratch, including the Linux kernel and all of the software that we just saw earlier, which is a great thing to achieve the cybersecurity question and the reproducible questions. But because you are fully independent to maintain it, the learning curve is very steep, and also you have a maintenance effort. So you don't have a community dedicated to support the SEAPATH built with the Yocto project tool. So that was the first philosophy that we wanted, mostly coming from the embedded world. And on the second hand, the community also asked to have a Debian support. So here you switch to an already pre-built OS, pre-built packages, so that you don't need to recompile everything yourself. But the maintenance is done from the community, which is a good thing because you don't have to do it yourself, but which can be also a bad thing because you are dependent on the community to integrate some modifications or to apply some patches, cybersecurity patches, for example. So it's really a question of, do you wish to be fully independent with the maintenance or not? That's the two established and official base for SEAPATH today, but there can be more to come in the future. I know that some people are interested to put also their OS at the base of SEAPATH. In both cases, Ansible is used for the infrastructure as code philosophy, so deploying the network and deploying the clustering stuff that I will show after a few slides. So that's it for the high-level presentation of SEAPATH. Now let's go into how do we enable the virtualization, protection, and control in SEAPATH? How do we ensure that all the requirements are met to run vPACs? First, how do we ensure the technical requirements are met? So let's take back our list of requirements and see how we can answer to that. I will go in more details in the next slide. That the virtualization question first is provided by QEMU, KVM, and LIMVirt. So that's something that is given by the open source software or already well-established open source software. The high availability is handled by a clustering feature that we developed on SEAPATH. The infrastructure as code is provided by Ansible, so describing all your hardware and deploying everything with the Ansible tool. The cybersecurity question is a real tough one, especially with CRA coming in Europe, for example. So we have chosen to be compliant with one of cybersecurity norms. I will also describe it. The minimal services and configuration is also tested in SEAPATH, so we ensure that only the required software is installed into the machine. Then the low network latency is a matter of Linux system configuration that I could also describe briefly, and the real time is the Linux kernel configuration. Let's go into a bit more details. For example, the real-time virtualization question. So many projects already tackle the real-time questions, but you don't have so many projects to tackle a real-time virtualized questions. In our case, the idea is that both the hypervisor, so the physical machine, and the virtual machines are running the real-time Linux kernel. That's something really important because the hypervisor schedules the virtual machine, so it should be real-time to respond at the correct time, but the software that is running inside the virtual machines must also be real-time. The important thing also to tackle at this level is that multiple VMs are running on the same hypervisor. So all of these VMs, which can be from different providers, uses the same resources. So same CPU, same disk, same network, same volatile memory, and things like that. And it's really a thing to configure, to take care of, to have dedicated places for each VM to ensure that all of them can answer correctly to the network packets that they receive, but also that they don't use too much CPUs or too much RAM and go into other VMs territory. So that's really the heart of the SEAPATH project, which is this configuration, this real-time virtualization question to have multiple VMs, multiple provider VMs running on the same hypervisor. We have also some dedicated conferences that I will show at the end that tackle specifically this problem and how we are going to achieve this question. Let's talk a bit about infrastructure as code also. I spoke already the role several times, but what is it? What's the idea behind that? So the very first question to ask is, how do we ensure that the infrastructure is correctly configured? How can we scale from when we have something into deploying it into multiple substation or multiple hypervisor in a substation? And some of the idea in the market is to have web UI so that the technician can click on to deploy everything. That's something that we didn't want on SEAPATH because we don't find that reliable. we can't really know what is deployed, and we can't really be sure that no one has been making any mistakes. So the infrastructure as code philosophy is to write code snippets that describe your infrastructure. That should be a fully declarative point of view. So you really write how many hardwares do you have, how many virtual machines do you have. It should be fully reliable and reproducible. So you can have the same setup in the lab and on the field. And on top of it, this technique can also allow versioning of infrastructure. On SEAPATH, we use Ansible, which is a Red Hat maintained tool well used in the data center on cloud infrastructure, and that also helps us to achieve this infrastructure as code philosophy. Now, let's deep into the continuous integration and development, which is one of the very important topic to ensure that everything is running correctly on SEAPATH and that SEAPATH can meet its requirements. First, what is the SEAPATH CI? So the SEAPATH CI is an open process. It is run on a GitHub Action, as you can see on the right. It's fully open source, so you can see all the tests that are running, all the workflows that are running, and it is distributed in two different locations. One is at RTE, so at Jonage, and in France, and one other it has Savoir-faire Linux in Rennes, in our office where am I right now. All the tests are open source, which means also that if they are committed in SEAPATH, you can see the PR running with all the tests that we add or that we remove with the time. And this process is reviewed so carefully by the SEAPATH maintainer and SEAPATH community. We cannot disable or enable some tests without any review in the CI. The tests are mostly focusing on what matters for digital substation, cybersecurity, real-time, and latency tests. Let's go first into the cybersecurity question. So as I said, we are based on an international norm, cybersecurity norm, which is the ANSI BP28. So the ANSI is the French agency for cybersecurity, but the norm is international, and it is described as a norm to configure Linux systems with different cybersecurity layers. So you have one example on the right with a kernel configuration where they just tell very directly and very briefly what configuration you can put into your kernel and what you should be taking into account or not. On SEAPATH, we took this type of requirements and we wrote some tests about it. And to ensure that everything is working correctly, we have a matrix, a compliance matrix that's put into a mirror between all the tests and the requirements on the ANSI BP28 norm. That's what you see on the right and the bottom. So here we can see a tens of tests that are required to test the R9 requirements of the ANSI BP28, and that's basically all the kernel configuration that you have there. This is tested directly on physical hardware and for each reference hardware platform. Now about the real-time testing. So as I said, the real-time test should be done at an hypervisor point of view, but also in a VM point of view. So the software is running inside the virtual machines. It doesn't run directly inside the hypervisor. So we should ensure that the real-time is correct and the real-time latency are correct inside the virtual machines. For that, we are using cyclic test, which is a well-established tool on the Linux world to test real-time latency, and it is run inside the virtual machines. You can see on the right the example inside that is running inside the CI. So you can also have a look directly at the CI test reports where I just got this image from. And this is a short test, actually, on just 10,000 iterations. It lasts a few seconds, but we do longer tests over a week. This test is only for the pull request. It is run on every pull request on SEAPATH where we have something to modify. We just test back that the real time is still correct on a configured SEAPATH machine. So we have a hard limit at 100 microseconds that should not be exceeded. If it exceeds, the CI doesn't pass, and you cannot merge your code in SEAPATH. Last but not least, network latency, so to ensure low network latency. And for this topic, we have an IEC 61850 network latency test. So the idea is to be directly using what will be used on the field with SEAPATH, so 61850 network packets. We have a hardware in the loop strategy where we test directly on the hardware, on the official hardware that should be embedded into electrical substations. We send IEC 61850 sample values from a sender that we have inside the lab, and we measure the time between when the sample value is emitted by the sender and when it is available inside the virtual machines. So it goes into the network, all the switches and network cables, into the network card of the hypervisor, and into the virtual machines. That's really important for us because the application is running inside the virtual machine. And here you have exactly the time between when the sample value is emitted and when it is available for the applications to be taken care of. So that's the same idea we do on a histogram here, the same for the cyclic test latency. And we have a hard limit at 250 microseconds. If it exceeds, the CI cannot pass and you cannot merge the code. Again, that's a relatively small test on a few minutes, but we have longer tests running over the weekend. Okay, last very important topic to ensure SEAPATH requirements is the high availability cluster. So that's where we deal with the high availability question. What is the cluster? So since then, I was only talking about one hypervisor. But what happens if anything goes wrong on this hypervisor? Shall it be electrical problems, can happen, or hard faults on the hypervisor, or anything like that? So if you are in that case, you cannot recover from your system, and all the softwares are not running anymore. The idea for SEAPATH from the beginning was to duplicate this hypervisor. So having two hypervisors running virtual machines. And you could do something like just absolutely duplicating the hypervisor and running exactly the same thing on both hypervisors. Some TSO and DSO have chosen this path, but for SEAPATH, we wanted something more flexible. So the idea was to put the two hypervisors in a cluster. They are communicating together. And the virtual machines can run on one hypervisor or the other one. So it means that sometimes my virtual machine is running on the first one and sometimes on the second one. From the user point of view, this has no impact. So it doesn't know about physical hypervisor layer. It just sees that its VM is running correctly. I will present some of the scenarios where it can be useful. But just for you to know, this SEAPATH cluster actually needs a third machine, which is right here, which is an observer. So it's for complex technical questions about cluster, but you need to have at least 3 machines on your infrastructure for it to be high available. How is it designed? So we have the physical disk of the hypervisor running the Linux system, of course, and running a layer of distributed storage with Ceph. This layer is not bound to any physical hypervisor. It is using the SSD and the HDD on the hypervisor, but it is not directly related to any hypervisor. It is distributed over the cluster. That is very interesting for the VM that are running on the cluster. They can access this distributed storage wherever they are, and shall it be on one hypervisor or the other one. With the hypervisor, the 3 machines are running some management for resources and for storage to distribute the storage and the VMs on the physical machines. But for the VM point of view here, they don't have to bother of where they are running. They are just running their stuff, and the user won't see anything. Let's look at some cluster action scenarios. So first, you have the live migration. As I described, the VMs can run on one hypervisor or the other one, but they can also migrate. So if you are running on hypervisor 1, you can be switched to the other hypervisor without any impact on the software. So the user, the HMI user, let's say, won't see any difference. The protection application won't see any difference. And this happens without any reboots, without any impact on the software. This first scenario enables 2 main other ones, which is the maintenance and the load balancing. The maintenance ID is what happens if you need to replace one of the hypervisor, or if you need to change something on the physical hypervisor layer, and you need to shut it down. So you can migrate all the VMs to the other one. They continue running, they continue responding, the users don't see anything. And then you can shut down your hypervisor and do your stuff. So changing a disk, changing a fan, changing the machines completely, anything that could happen. Plug everything back into the cluster, and then the VMs can migrate back onto the first hypervisor. They are doing that by using the load balancing scenarios, which is the basic idea of we don't want all the VMs running on one hypervisor. We want to balance the power of the two hypervisors running different virtual machines. So all of these two scenarios uses live migration, and you have no impact on the cluster, on the user, sorry. Then that was when everything was great and working as expected, but the cluster can also prevent some problems. First of all, you can have some network failures, for example. If one Ethernet cable is down, you can detect that in the cluster and schedule VMs to run on other hypervisor, other physical machines. So it can be a different layer, but we can handle one link down on the cluster. You can also have some more advanced usage as what about a PTP disruption on the machine? If the PTP doesn't come and the machine is not synchronized anymore, we can schedule VMs on another machine. You can also have a hypervisor critical failure, as I described. If a power outage happens on a hypervisor, or if you have any problems on one physical machine, this is detected. The shutdown of the hypervisor is detected, and the VMs are restarted on another cluster, on another hypervisor on the cluster. This has an impact on the software, so 5 to 10 seconds downtime, but you don't need any manual intervention on the cluster. Everything is recovering alone. Then the last topic that is handled also by this technology is the excessive resource consumption of a VM. What happens if a VM goes crazy and is taking 100% of the CPU, for example? So this is also the goal of the SEAPATH and the goal of the cluster to ensure it doesn't impact any other VM that is running on top of the hypervisor. So that was the very big part of how to ensure that SEAPATH can run vPACs. Now let's talk a bit about SEAPATH integration, what we can do with hardware, what we can do with software, and what example we have to show to you. As I said, SEAPATH is hardware agnostic. So we don't want to be bound to one physical machine, one type of hardware. We are not selling hardware, we have an open source project. This means that the concrete impact it has on you is that SEAPATH has some requirements, but that are really standard. For example, today SEAPATH is only accept x86 machines. ARM machines are coming soon, but not right now. You need EUFI, so not legacy BIOS. We need some IOMMUs, and we need to have a PTP network card. But all these requirements, even if you don't necessarily understand all of them, are fairly standard industrial servers requirements. So if you take any today's servers on the market, it can run SEAPATH. Even no servers, because we are running SEAPATH on really tiny machines for a demo, for example. So the hardware question is not bound to SEAPATH. The hardware question is really what type of power do you need and how many cores, how many RAM do you need, or how fast, and things like that. On the right, you have two standard machines running SEAPATH. That's mostly what is running in the CI. That's, for example, for you to know. Those are not officially supported machines, but we have an official program that should begin soon, but not quite ready today. Many other machines are used to run SEAPATH, just not in the CI. So that's example. Now that we talk about the hardware, let's talk about the software and the virtual machines. What can run on SEAPATH? So many virtual machines can run on SEAPATH, but to give you some more official integration, I have put some example. First, it's the vIED integration into SEAPATH. So we have vPACs running on SEAPATH, like the ABB SSC600 software, a proof of concept with gvernova, and also some RTU that are ongoing today. Here on the right, you have an example of the SEAPATH wiki describing how to run the ABB 600 software inside SEAPATH and what are the configurations that you should tackle to deploy these virtual machines on SEAPATH. So that's something that you can already do. Regarding the technology supported on the OT wall, so it's also an important topic. SEAPATH is running all the networking technology that are needed in the industrial electrical substation. So first, about the time synchronization. The precision time protocol is of course supported. The NTP protocol is also supported as a fallback when PTP is not present to preserve a time limit. We support redundancy protocol like PRP and HSR, and we also support advanced networking protocol like SRIOV to bring lower latency levels into the hypervisor and in the virtual machines. Let me describe also you a bit the proof of concept that we have done with GE Vernova that we have presented last year. So this is a project managed by National Grid, which is the England TSO in England, and it's a proof of concept of a vPAC running on SEAPATH. So a demo was organized at the last LF Energy Summit in 2024 with very promising results. So we have a protection tripping in under 8 milliseconds. You can actually read the case study that was written on the LF Energy website, where we describe also all the test setup. We had the Omicron and merging unit running with an Advantex server, so you can have all these informations into the case study. And we have done, so there have been done 2 conferences on the topic, one with Camilo Di Arriba from Gvernova and myself, and another one that was on just a few months ago by Thomas Charton from National Grid, which is giving a higher level point of view on the project. Now let's end this presentation with the SEAPATH community, how you can get in touch and how you can participate if you wish to. First of all, about the SEAPATH onboarding. So we have many different links and many different websites. All of these slides handle clickable links. It will be available at the end of the webinar, so we can go back into this slide and just click on the different links. But let me just describe it a bit. The very base page of SEAPATH is the LF Energy web page. So all of this should be accessible on a standard web search engine if you look. From the LF Energy page, you have basically the links into all of the other items here. The GitHub landing page is also give many important stuff about the project, maybe a bit more technical. And if you wish to have easier access to what is SEAPATH and more in-depth content, you can go look into the YouTube playlist, which is on the LF Energy webpage, and LF Energy YouTube channel. Sorry. We have many conferences there and some technical tutorials also. If you want to join the community, you can contact us with mailing list or Slack. We're present on the LF Energy Slack. Most of the discussion happens in Slack, but don't hesitate to ask your question on the mailing list also. It's made for that. You have more, let's say, commercial and demonstration post on LinkedIn also. We are active on this LinkedIn page. And regarding the documentation, most of the documentation is on the SEAPATH wiki on Confluence, which was just been remade completely and beautiful a few months ago. So don't hesitate to take all your information there. And on the very technical level, the documentation is accessible also on the Ansible Galaxy and on GitHub. But that is if you really wish to deploy the tool and to get hands-on into the project. Very important last topic. We have one technical steering committee every month. This is organized by the LF Energy, so it's pretty standard procedure. But everyone can join. It's a Zoom meeting, and if you wish to just hear about the last SEAPATH news or to go into some technical questions, feel free to come on the TS. About the conferences, so we have done many international conferences with SEAPATH. All of them are on the SEAPATH YouTube playlist on the LF Energy channel. I put some example on the left here about the most important one, let's say. So the first one is the G Vernova proof of concept of vPAC on SEAPATH, which you can find pretty easily. RTE has done many different conferences, but this is the name of the last one, which was done by the R&D team. Of course, the presentation by Thomas Charton, which SEAPATH used on the England National Grid Electricity Transmission. And last one, which is a bit more technical, about implementing cybersecurity questions on SEAPATH, if you want to go how it is made, if you want to see how it is made. The SEAPATH community is growing. So currently we have 7 utilities and 11 different vendors evaluating or using SEAPATH in general. We have many SEAPATH initiatives in the world. I put the most advanced one here. So RTE is leading 2 of them. The airspace project is an industrial use case of SEAPATH. This one is actually very interesting because it's production usage of SEAPATH in primary substation, small primary substation, and for non-critical application from now. So the protection applications is still running on hardware boxes, but SEAPATH is running all the non-critical stuff in production. And regarding the protection algorithm, it's actually the Viper R&D project, which is evaluated by RTE with ABB protection and Schneider Electric also developing a protection. The last one is the proof of concept we shown with G Vernova that is going well and also going into more advanced steps today. There is a list on the SEAPATH wiki that you should find pretty easily of all the SEAPATH initiative and all the utilities evaluating SEAPATH if you want to get in touch with them. So this is all the community of SEAPATH for the last slide. So RTE and Savoir-faire Linux, we are the main companies that are developing SEAPATH and maintaining them today, but we are joined by many other companies, so Allianders that also start the project with us. Enedis, which is the French DSO, is evaluating SEAPATH. Red Hat and Smile are also developing on SEAPATH and wishing to propose some support on SEAPATH. Grid2Great wish to deploy their solution as a software on SEAPATH. Elia is investigating the SEAPATH project for the substation, and ABB and Schneider are directly in touch with RTE to make their vPAC accessible on SEAPATH. That concludes our webinar. Thank you all. And now if you have any type of questions, feel free to ask them now, or maybe there are already questions that Dan, you can read to me.
Yes, thank you for the great presentation, Erwann. There was one question which I already typed an answer to, but just for anyone who joined late, we did record this. The recording will be shared out via email, along with a number of the links that Erwann had shared and the slides. So you all will be receiving that. But yes, if anyone has any additional questions, please use that Q&A button in the Zoom interface. There is one question currently pending, and this is, can we try to map this into existing SAS architecture?
I'm a bit embarrassed there because I don't know exactly about SAS architecture. Maybe you can be a bit more describing. Maybe I know that, but only the French acronym, I'm not sure. Or Dan, if you know about this word.
SAS is the large German software company.
Okay. Sorry, but me not knowing on
Sorry,
that.
that's what I was assuming, but no, it's actually substation automation systems is what they meant in this case.
From the name, I'm pretty sure that we can, yes, but I'm not aware of the project and the system directly. If you wish to get in touch with us, please just write a quick email on the mailing list, and we can see about that. And let me maybe just expand a bit on this question, more general question on the what projects can we get in touch to, or can we integrate with? So there are actually also plans to integrate with some LF Energy other projects. So mostly the Compass and Fletch Power projects. That's absolutely something that we can do. That's not ready today, but that will be done in the future. And I'm pretty sure it can be integrated with some other topics. Let's keep in mind that the very basic idea of SEAPATH is that because it's open source and it's a very permissive license, the idea is for everyone to cooperate on that. but you don't have to get official support or to pay anyone to integrate with SEAPATH. So if you wish to integrate your solution with SEAPATH, you can do it directly. I strongly encourage you to do that on the SEAPATH project directly, because it's better to have everyone on the table. But technically, you don't need anyone's permission to use SEAPATH, to test SEAPATH, and to integrate with.
So just to clarify, the person asking the question meant substation automation systems architecture in terms of process bus, station bus, etc., asking if CPATH can integrate with those. If you
Yeah,
have an
yeah, yeah.
existing architecture already.
Of course. So that was the goal of the first schema that I show. This one about CPaaS. So actually, I'm more of an IT guy, so I'm working mostly inside the hypervisor level. But RT is doing a lot of stuff with um, the ISC 61850, yeah, SAS, I think that's the goal, and the process bus and station bus. You can go look into the wiki. There is a more detailed description of what RT is building that I don't know a lot about myself because I'm not an OT expert, but pretty sure you can find your answers there.
Perfect. Then we have another question. If I understand correctly, CPATH targets both TSO and DSO, correct? Which are you putting more priority on?
So both, but for I would say for now, because the project has been driven by RTE, most of the architecture is sought for TSO, or at least for large electrical substation. So RTE is willing to use CPaaS in all their electrical substations, so no technical restriction other than being ready to deploy that. For example, in France, Enedis, so the DSO, the main DSO in France, is also willing to use CPaaS or evaluating CPaaS for their primary substation, so their biggest substation. There has been some investigation to also bring CPaaS into the secondary substation level. So we are also getting in touch with the vPAC Alliance to see how much synergy we can have with this project, or more directly with some DSO to have a CPaaS running on very smaller hardware with smaller capabilities to go into very small substation. So I would say both of them, but today it's more ready for TSO than for DSO.
Perfect. Then next, if a company decides to use this hypervisor, is there a third-party entity that can provide support for it?
Yeah, of course. We, it's going a bit commercial now, but as a company, my company, Savoir-faire Linux, is providing support, official support for CPaaS. So you can contact us if you wish to have any. Now, if I put aside my commercial ideas and just talking about the open source the open source philosophy, the important thing is that you have all the code and everything ready. So if you want to get in touch with any support companies that you know, you can ask them if they could give an official support for CPaaS, because they have everything in hand. Once again, they don't need they don't need to ask anyone to provide support for CPaaS. The code is there and that can do that. So if you want to have support directly, you can come to us, but technically you can come to any support companies that is willing to do some support for CPaaS.
Perfect. Next, as SRIOV needs specific hardware, is it
Yeah.
mandatory to meet the latency requirements?
So that's a bit more technical, but so SRIOV is, yes, a technology to allow low latency network. It's not the only one, and actually we are investigating all other technologies like PCI pass-through, for example, or even some Linux bridges, but it's not it doesn't meet the requirements today, and so SRIOV is not needed to run CPaaS or even to run some vPACs. The proof of concept we have done with GE used PCI pass-through, and the network card doesn't support SRIOV. But from the more personal experience that we have, we think that is something that will be used by most of the users of SEAPATH, because it provides even lower latency, and it's really useful technology to have multiple VMs connect to the same card. So it's not mandatory, but in the end, I think you will want to use one.
Perfect. We have another question. How does SEAPATH schedule multiple protection VMs together?
Yeah. So the basic idea that we advise today is to schedule each protection on the dedicated CPU cores. So as you may know, today a CPU is multitasking, so you can run multitask, but you can also have multi-cores on the same CPU. It's almost if you have multiple CPUs. And we advise to use some of these CPUs to run one protection algorithm, one virtual machine, some other CPU to run the second one, and the rest of the CPUs to run the hypervisors and the non-critical VM stuff. That's how you ensure from a CPU point of view that you don't have any problems. If you're talking about the RAM or the disk access, it's a bit more complicated, but for the RAM, we are pre-allocating all the memory that the virtual machine needs. So it's fixed from the start of the virtual machines, and no one can use this memory. So it's pretty easy. For the disk point of view, it can be a bit more complex. So it's more a question of I/O scheduler and I/O priorities that needs to be tackled. But usually, from what we have saw, the virtual machines the virtual protection doesn't use so much disk, and that's not the limitary factor. The limitary factor is the CPU, of course, and the network latency. So going back onto this question of which network technology do we use? Do we use SRIOV? Do we use PCI pass-through? I think you can go look at the GE Vernova POC that we deployed. There is a conference on that, and we tackle some of these topics more precisely.
Perfect, thank you. Then we've got another question. How does the project deal with paid or non-public IEC 61850 standards as an open source project?
Yeah. So again, I'm not an expert into the OT world, so I see two sides of your questions, but let me know if I'm not answering correctly. One side is the norm. So how do you construct the network packets? What is a sample value? What is a good message, and things like that. Technically, today, the hypervisor doesn't need to know all of that. So the only one needing to know this stuff is the virtual machine. And so that's the provider of the virtual machine that's paid license and have all this legal stuff doing. SEAPATH is only running the virtual machine, but is not providing any virtual machines. So we don't need to have this question directly tackled. Another side of the question could be maybe how do you handle license on the applications itself? So for example, ABB today is providing virtual machines, but is also providing some different licensing questions with their virtual machines. And we don't have necessarily problems with that as long as we can run the virtual machines, because again, from a SEAPATH point of view, we are just starting the virtual machines, giving the resources and isolating correctly all the virtual machines and running them. Everything that happens inside is the question of the provider. So that's not directly from us to answer this question, but more the virtual IED provider.
Wonderful. Then next, could you elaborate on the viability and pertinence of SEAPATH specifically for smaller industries or substations? Are there anticipated challenges or key advantages that would impact its adoption and effectiveness in these types of settings?
Yeah, there are many questions, more than challenges, I would say questions. So I think the two most, so let's start with that. All of the SEAPATH requirements and the technical answers that we gave, so basically the open source project that we are using, comes from the requirements from TSO and from big substation. That's what I meant in the way that it can be used with DSO, but it's not necessarily the exact good solution today. Let me just take two examples. First is the virtualization question, because running a virtual machine costs much CPUs and much RAM, and sometimes you don't want to do that. Second one is the real-time questions. I don't have the answers for both of them, but I know that many DSOs are thinking about it, do we really need virtual machines and do we really need real time? So it can be put into questions whether or not those are the correct tool to use. Today, what we are doing in the SEAPATH project concretely is that we are also going into the containerization question. For those who don't know the container world, let's think about it as a very tiny virtual machines with less isolation, and it costs less RAM and less CPU and all of that. And we are investigating that today. We are running containers on SEAPATH. The idea would be maybe that DS and the smaller substation runs the SEAPATH with containerization instead of virtualization. Maybe the last question to ask would be about the redundancy. We don't necessarily want to put two not hypervisor, but two physical machines into a small substation. That's also, regarding on the scale of the substation, that's also a question to ask. So I would say today, the question is more about what is the need for smaller substation, which is not fully clear, at least on the SEAPATH project side. It's less the question of the requirements than the answer that the technical answer that we will give to that.
All right, there were no other open questions. We do have about 2 more minutes, so we can
Yeah.
give it a couple seconds in case someone wants to submit a last second question. Here's one. Is it possible to use something? Is it possible to use something other than Slack? I can address that one. That's not a question for CPATH. That's a question for the LF Energy Technical Advisory Council, which has received this question many times and has considered other communication platforms, but the majority have said that they prefer to stay on Slack for the time being. So it is something that both LF Energy staff and our TAC have looked into, and as a staff, we're open to it. There are a lot of other tools out there, whether it's Discord, Zulip, and others, but for the time being, the technical leadership has, at the LF level, has decided to stick with Slack.
And if I can add something, maybe it's not better for you, but you still have the mailing list, which is basically sending a mail onto every person registered onto this mailing list. So we are, of course, on it. All the maintainers of SEAPATH, the TSC chair of SEAPATH is also on it, and you can ask your question there if it's better for you.
Perfect. Well, with that, I will once again thank Erwann and thank all of our attendees for joining us today. Just a reminder, you will all receive an email once the video is ready and uploaded with a link to that, as well as the slides, and we'll also share some links to learn more and to get involved in the CPATH project. So thank you again. We hope to see you at another webinar soon.
Thank you.